High in the eastern Carnic Alps of Italy, in a region called Friuli Venezia Giulia, there's a forest that most tourists never see. It's home to one of Europe's rarest treasures for woodworkers, the Abete Bianco, or European silver fir. Unlike most conifers, this tree has no resin pockets. That means its fibers stay clean, compact, and incredibly receptive to treatment, a builder's dream material. Back in 2016, 8 local businesses banded together to protect and celebrate this wood, forming a network called Friul Dane. Loggers, sawmill operators, marketers, and technical support companies, all under one shared mission. Their proving ground came when the Bianchi Mountain Shelter, a rustic refuge deep in the Val Alba Nature Reserve, needed a full rebuild. The team set a strict rule. Every single board had to come from silver fir harvested within their own certified regional forests, a true zero-kilometer supply chain. No imported lumber, no shortcuts. Loggers felled selected mature trees under PEFC sustainable forestry standards, then hauled the logs to regional sawmills for primary breakdown. From there, the timber moved through drying and planing before reaching the carpenters who reassembled the shelter beam by beam, high in the mountains. The finished refuge became the 5th PEFC certified building project in Italy, and the 9th in the entire world. Proof that a forest, managed the right way, can rebuild itself into shelter, tool, and legacy all at once. It's a small operation by industrial standards, but it captures something bigger, the idea that good wood, handled with patience, outlives the men who cut it. Deep in the rolling farmland of Lorraine, in northeastern France, sits a sawmill that has been cutting timber since before automobiles existed on French roads. The Scierie du Rupt de Maude, based in the small village of Bayonville-sur-Maude, traces its roots back to at least 1876. Picture that for a second. This mill was already running when horse-drawn wagons were still the primary mode of transport. In its earliest decades, one of its specialties wasn't furniture or flooring at all. It was wooden wheel hubs and spokes for carriages, cleverly alternating oak for hardness and acacia for flexibility to build a wheel strong enough to survive rutted country roads. The mill even endured occupation during the First World War before returning to full production. Fast forward to 1987, and the operation faced liquidation. A businessman named Mr. Rutten stepped in, bought the struggling mill, and poured serious capital into new machinery and expanded storage buildings. That investment set the foundation for the modern facility you'd find there today. In 2008, leadership passed to Bertrand and Sophie at PRL, with Rutten staying on as chairman to guide the transition. A rare case of continuity in an industry where family sawmills often disappear after a single generational handoff. Today, the Rupt de Maude sawmill processes somewhere around 15,000 cubic meters of timber every year. That's roughly the volume of 6 Olympic swimming pools worth of raw logs turned into finished lumber annually. Their specialty is oak and ash, sourced almost exclusively from the forests of Lorraine and Burgundy. Much of it supplied through partnerships with France's National Forestry Office, the ONF. The process begins the moment logs arrive on site. Each log is inspected and sorted by species, diameter, and grade before it ever touches a saw blade. From there, the timber moves into primary breakdown, where modern saw lines slice the raw logs into rough boards and beams, following cutting patterns designed to extract maximum value from every trunk while minimizing waste. This is where old-world craftsmanship meets modern precision. The mill runs what they describe as a modern production tool applying traditional methods, meaning skilled sawyers still make judgment calls that automated systems can't replicate, reading the grain, spotting knots and stress points, and adjusting the cut in real time. Once boards are cut, the real transformation begins: drying. Freshly sawn oak and ash are loaded onto open-air storage racks first. These sheds are deliberately positioned to catch prevailing winds, allowing a slow, natural pre-drying process before the wood ever sees a kiln. This step matters enormously. Rush a hardwood like oak straight into artificial heat, and you risk cracking, warping, or case hardening the timber from the outside in. After this natural pre-drying phase, boards move into the mill's serious drying infrastructure. 9 kilns with a 100 cubic meter capacity each, plus 4 additional kilns rated at 80 cubic meters. That's 13 separate drying chambers running in parallel, giving the mill enormous flexibility to handle different species, thicknesses, and moisture targets simultaneously. Alongside the kilns sit 2 massive climate-controlled storage buildings covering nearly 7,000 square meters combined, roughly the footprint of a large big-box hardware store. These buildings keep dried lumber stable and ready for shipment, protected from humidity swings that could undo months of careful drying work. The mill doesn't just process its own stock either. They offer custom sawing and custom drying services for outside clients, meaning a customer can bring in their own logs and have the Rup-to-Mad team handle everything from milling to moisture control, applying the exact same rigor as they do to their in-house production. Every board that leaves the facility carries PEFC certification, verifying it came from sustainably managed forests, an increasingly important detail for the parquet manufacturers, furniture makers, staircase builders, and carpentry shops that make up the bulk of their client base. And this isn't a company standing still. Ownership has continually reinvested in the site, expanding drying capacity and storage as demand has grown, with plans on the books to keep building new kilns and doubling stockpile capacity in the years ahead. What makes this operation remarkable isn't flashy technology or record-breaking output. It's longevity and discipline. Nearly a century and a half of turning Lorraine's oak and ash forests into some of the finest sawn hardwood in France, using a philosophy that hasn't really changed since the days of wagon wheels. Respect the wood, dry it right, and never rush the process. Plywood might be the most underappreciated material in modern construction. It's in your walls, your subfloors, your furniture, your moving boxes, and yet almost nobody thinks about how it's actually made. In the town of Niksar, in Turkey's Tokat province, a company called Nikantaş Kontraplak has built its entire business around perfecting that process. Nikantaş operates as a producer and direct seller of plywood, running its manufacturing plant in Niksar while maintaining a dedicated sales facility in Ankara's Sitler district, a hub known across Turkey for woodworking and furniture trade. From there, finished panels are distributed to customers nationwide through a network of regional warehouses. So how does a log actually become a sheet of plywood? The process starts with selecting suitable logs, typically fast-growing softwood or poplar species prized for straight grain and manageable density. These logs are debarked and often steamed or soaked to soften the wood fibers, making them easier to work with in the next stage. From there, the logs move to a rotary lathe, a machine that spins the log against a long, razor-sharp blade, peeling it like an apple into one continuous, paper-thin sheet of veneer. This is genuinely one of the most satisfying processes to watch in all of woodworking, a solid cylindrical log unwinding into a seemingly endless ribbon of wood. The resulting veneer sheets are then clipped to standard sizes and sorted by quality, thickness, and visual grade, since not every sheet is destined for the same use. Lower grade veneer often ends up as interior core layers, while the cleanest, most defect-free sheets get reserved for the visible face layers of the finished panel. Next comes drying. The veneer sheets pass through large drying chambers that reduce moisture content to a precise target level, critical for what happens next, gluing. This is where the real engineering of plywood comes into play. Layers of veneer are stacked with their wood grain running in alternating directions, one layer horizontal, the next vertical, and so on. That cross-grain construction is the entire secret behind plywood's strength. It distributes stress in multiple directions, resisting the warping and splitting that solid wood boards are prone to. Adhesive is applied between each layer using automated glue spreaders, and the stacked panel, sometimes called a layup, moves into a hot press. Under intense heat and hydraulic pressure, the glue cures, and the individual veneer sheets fuse permanently into a single rigid panel. Nikantaş produces several specialized variants using this core process, including waterproof plywood for exterior and marine-adjacent applications, fire-resistant panels treated with flame-retardant compounds for commercial construction, and decorative plywood finished with attractive face veneers for furniture and interior design use. After pressing, panels are trimmed to final dimensions, sanded smooth, and run through rigorous quality control inspection, checking for delamination, surface defects, and dimensional accuracy before anything ships out the door. In the Swedish province of Dalarna, just a few kilometers from the starting line of the legendary Vasaloppet ski race, sits one of Sweden's largest privately owned sawmills. Fiskarhedens Trävaru AB has been cutting timber since 1923, when a local man named Johan Jakobsen returned home from a stint working in the United States with savings in his pocket and a vision for a modern sawmill in his home village. A century later, that vision has grown into a facility producing well over 360,000 cubic meters of sawn pine and spruce every single year, with more than 85% of that output shipped to buyers outside Sweden entirely. The Larsson family has owned and run the mill since 1988, currently led by Magnus Larsson, who grew up around the sawdust and machinery before taking the reins from his father. What sets this operation apart is how far it's pushed digital technology into a traditionally low-tech industry. The process actually begins before a single log arrives at the mill. Harvesting machines in the forest capture precise measurement data as trees are cut, and that data shapes production planning before the timber even leaves the woods. Once logging trucks deliver pine and spruce to the mill, independent timber measurers scan and sort every log by size into a system with dozens of separate categories. Then comes the real showstopper, a CT log scanner, essentially an industrial X-ray machine that sees straight through the bark to map each log's internal density, knots, and hidden defects before it's ever cut. That data follows the log through the entire production line, guiding the saw system to slice each trunk in the exact pattern that extracts the maximum value from what's hidden inside. After sawing, boards pass through a strength grading machine capable of certifying lumber up to structural class C40, verifying it meets European building codes for load-bearing construction use.